Hi, I am Arib. You are watching my YouTube channel. Power cable. Definition. A cable used for the transmission and distribution of electrical energy is called electrical power cable. Power cable consists two or more electrical conductors joined with an oversheath. It is used for the transmission of extra high voltages in a place where overhead lines are impracticable to use, like the sea, airfield crossing, etc. But underground cable is more costly as compared to aerial cable for the same voltage, which is one of the main drawbacks of electrical power cable. Construction of cable. The power cable mainly consists of three main components, namely conductor, dielectric, and sheath. The conductor in the cable provides the conducting path for the current. The insulation or dielectric withstands the service voltage and isolates the conductor with other objects. The sheath does not allow the moistures to enter and protects the cables from all external influences like chemical or electrochemical attack, fire, etc. Types of power cables in electrical systems. Electrical systems use different types of cables depending on voltage level, environment, and application. Below are the main types explained in detail. Low tension (LT) cables. Low tension cables are designed for distributing electricity at low voltage levels. These cables are widely used in homes, offices, and small industries. They are easy to install and maintain. Because they operate at lower voltage, they require moderate insulation thickness. LT cables ensure safe and efficient power supply for lighting, appliances, and machinery. Cable standards define important factors such as insulation type, voltage rating, fire resistance, mechanical strength, and testing requirements. Compliance with these standards not only guarantees safe electrical installations but also ensures that cables meet regulatory requirements across different regions. High-tension (HT) cables. High-tension cables are used for transmitting electricity at higher voltage levels, usually above 1 kV and up to 33 kV or more. These cables are commonly installed in industrial plants, power stations, and large infrastructure projects. HT cables are designed with thicker insulation layers to handle high electrical stress. They often use XLPE insulation due to its excellent thermal and electrical properties. These cables reduce power loss during long-distance transmission and support heavy electrical loads. Because of their strength and durability, HT cables are suitable for demanding industrial environments. PVC insulated cables. PVC, polyvinyl chloride, insulated cables are one of the most commonly used cable types in residential and commercial wiring. PVC provides good insulation, flexibility, and resistance to moisture and chemicals. These cables are ideal for indoor wiring, light-duty industrial applications, and electrical appliances. They are affordable, easy to handle, and suitable for moderate temperature conditions. However, their heat resistance is lower compared to XLPE cables. XLPE cables. XLPE stands for cross-linked polyethylene. XLPE cables are known for their superior electrical and thermal performance. They can withstand higher temperatures and carry more current compared to PVC cables. These cables are widely used in underground installations, industrial power distribution, and high-load applications. XLPE insulation provides excellent resistance to moisture, chemicals, and environmental stress. Because of their durability and high efficiency, XLPE cables have a longer. Armored cables. Armored cables have an additional protective layer made of steel wire or steel tape. This protective layer shields the cable from mechanical damage, physical impact, and external pressure. Armored cables are commonly used in outdoor and underground installations where cables are exposed to harsh conditions. They provide extra safety and durability, making them suitable for industrial areas and construction sites. Unarmored cables. Unarmored cables do not have the additional steel protection layer. They are generally used in indoor applications where there is less risk of mechanical damage. These cables are lighter, more flexible, and easier to install. They are commonly used in control panels, switchboards, and internal building wiring systems. Flexible cables. Flexible cables are specially designed for applications where frequent movement or bending is required. They are made with multiple fine copper strands, which make them highly flexible. These cables are used in portable electrical tools, machinery, equipment, and appliances. Their flexibility reduces the chances of conductor breakage and increases the lifespan of moving electrical systems. The uses and benefits of power cables. In almost all sectors where electricity is needed, power cables are commonly used. Here are some of the most common applications: electrical wiring in the home, including connecting lighting, appliances, and other electrical systems. Commercial, providing power to offices, hospitals, and malls, etc. Industry, heavy machinery, motors, and other equipment used in factories. Infrastructure, transmission of electricity through power grids and substations. Conductor material. Copper is a high-conductivity metal that's ideal for applications requiring heavy-duty materials. Aluminum is lightweight and economical, making it ideal for long-distance transmission. Insulation materials. It is ideal for environments with high temperatures because it has excellent electrical and thermal resistance. PVC is flexible, durable, and resistant to chemicals and moisture. Voltage rating. Make sure the voltage rating of your cable matches what you need, either low voltage, LT, or high voltage, 11 kV. Conclusion. Selecting the right power cable is crucial for ensuring safety, efficiency, and long-term reliability in any electrical system. Each cable type, whether LT, HT, PVC, XLPE, armored, or unarmored, offers specific features and benefits suited to different applications and environments. Proper understanding of these cable types helps in making informed decisions for residential, commercial, and industrial projects. Behind every high-quality cable is advanced manufacturing technology. Sani Engineering, a reputed wire-making machine manufacturer and power cable plant manufacturer, provides modern and efficient machinery that supports the production of reliable, high-performance power cables meeting industry standards.